Hey, what's up, everyone? Today we're going to be looking at solving quadratics by factoring. Now, if you've been following along in my classroom, we've been kind of skipping around just a little bit. So the too long don't read version of this is simple. Quadratics are a type of equation, kind of like we have over here, where we have y equals x squared plus 3x minus 10. Now, this is just an example. Usually the equation looks like y equals ax squared plus bx plus c. And this should look very familiar to what we've been doing recently, especially with trinomials, because really what we've been focusing on is just the x squared plus bx plus c aspect of it. The a represents another coefficient that would normally be on the first x variable, but more than likely we won't really see that today, which is a nice thing. So really what we're going to be doing is we're going to take the factoring that we've been talking about recently, and we're going to use it, we're going to put it to good use to solve an equation. So let's kind of just jump into this. In many cases, we can find solutions. Solutions, hopefully you remember that word from our solving equations unit. Or we might often call them roots, zeros, x-intercepts. They can be known as any one of these things. We can find the solutions of a quadratic equation by factoring instead of graphing. Now, of course, we've been skipping around, so the graphing we didn't look at so much. So we're going to follow the steps below to solve a quadratic equation by factoring. So first things first, it's important to know that a quadratic equation is, of course, y equals x squared plus bx plus c, kind of like what I have over here. Now what we're going to do is we're going to take out that y, and we're going to set our equation equal to 0. So x squared plus 3x minus 10 equals 0. Okay? So really all we're doing, taking out the y, and we're throwing the equal sign to the other side of the trinomial. We're putting it equal to 0, and we're going to go from there. So the only thing really that we're adding on to the trinomials we've been working with is we're setting our trinomials equal to 0. All right? Now, the thing that you should be familiar with is factoring the left side. Notice step 2. We need to factor this trinomial, so x squared plus 3x minus 10. Now, hopefully you're familiar with this, because what we have been doing, and I'm just going to take this over just a little bit. For those of you who were here last week, and for those of you to recall, factoring. To do factoring, I like to do what we call the x games. And so I draw like this little x, and whatever my c is, I put in the top, and whatever the b is, I put in the bottom, in this case 3. Now I need to find factors of 10 that are going to have an addition or subtraction that results in 7. And so for this I can think, oh, 1, 10, 2, and 5. And there aren't really any others, so it looks like 2 and 5 is it. I want 2 and 5 to come out to 3. Now here's how we determine which factor is going to be negative. And hopefully you see one of these is going to be negative because our multiplication should add to a negative 10. So 2 times 5, one of these is going to have to be negative because this is a negative 10. Well, since this is a positive 3, it looks like our 5 is going to have to be positive and our 2 is going to have to be negative. So we can test that out. Negative 2 times 5, negative 10, yes. And then negative 2 plus 5, if I plug that in a calculator, positive 3. Good. So negative 2 and positive 5 are the factors that we want. And so to do this, put this in factored form, I'm going to have x minus 2 times x plus 5. Now here's something we're not used to. We're going to have to keep this equal to 0. Remember, this is an equation now. So we need to keep this in a factored form, so to speak. And yeah, I'm going to try to move this over to the side. That way we don't have to worry about it. Woo! It just disappears. So we're going to keep this equal to 0. And to solve a quadratic equation, first we factor it, like we have in step 2. Then we're actually going to set each factor equal to 0. Now, what do I mean by each factor? I mean each thing in parentheses. Each thing in parentheses represents one factor of the trinomial. So we're going to take each of these. So we're going to take x minus 2, and we're going to take x plus 5, and we're going to set each of these equal to 0. Now this is actually called the zero product property. which basically says, well, if our quadratic equation is equal to 0, then one or both factors should equal 0. So that's how I'm doing it. Since our equation equals 0, one of these must equal 0, so we're going to test this out. Now, really, these are just one-step equations now, and I hope you see that. X minus 2 equals 0. Well, all we have to do is add 2 to both sides, and we find that x is equal to 2. That's one solution. But the thing about quadratic equations is they usually have at least 2. So if I look at this, x plus 5 equals 0, I have to subtract 5 from both sides. So x equals negative 5. Now, I know that what we're looking for, we want to write this answer in curvy braces. What the heck does this look like? Ladies and gentlemen, the curvy braces is as simple as this. They want us to write our answer like this. So it's like a brace, but it's got the curve. And we need to write this as 2 comma negative 5. Now, of course, this is different from a coordinate point because this is not parentheses. If this were in parentheses, it would be a coordinate point, but that's not what we want. So we write our solution as the curvy brace 2 comma negative 5, and then curvy brace again. So this is the new technique that we're looking at today. So I hope you'll follow along. We've got something like 6 examples to go through. I think you're going to find this very simple. We're going to start out with numbers 1 and 3. And like I do, I'm going to zoom in. That way I have more space and you can see this quite clearly. Here's what you want to focus on. All right, we're going to solve the following quadratic equations by factoring. That's what we just did, okay? So I need to look at this, look at the trinomial. Notice that it's already equal to 0, so I don't have to worry about that step. I need to factor this trinomial. And if you're like me and you've already got this down, I'm going to set up my X games, as we like to call it. My C is 3, so that's going to go up top. My B is 4. So I need factors of 3 that add up to 4. Well, guess what? 1 and 3. And I know that neither of them are going to be negative because, number 1, my C is positive. So if my C is positive, remember that my signs are going to be the same. And then my B is also positive, so they have to add together. So this tells me that my factors are x plus 1 and x plus 3. And they're still equal to 0. All we need to do now, the next step, the next piece to this, is just setting each factor equal to 0. So x plus 1 equals 0, x plus 3 equals 0. And then all we do is solve for x. So this is just one extra step. Well, it's actually 2 extra steps, but 1 per. So subtract 1 from both sides, x equals negative 1. Subtract 3 from both sides, x equals negative 3. And then all we do, oh, that's a negative. All we do then is put it in our curvy braces, as they're called. So negative 1 comma negative 3. Did I go too fast for you? Let's try and slow it down. We're going to look at number 3 too. Like I said, we're going to do number 3. And I've got x squared plus x minus 2 equals 0. Okay. Like our step says, step 1 wants us to set the equation up, set it equal to 0. Well, that's already done. We need to factor this out. All right, so we need to factor this trinomial. And I see that my b is going to be 1. My c is this negative 2. So let's set up our x games. C here is negative 2. And b is positive 1. So what this is telling me is that I need to find factors of negative 2 that add up to positive 1. And really, there's 2 ways that this can go. The only factors of 2 are 1 and 2. So this is going to tell me that one of these is going to be negative. And hopefully, if I need a negative product, but I need a positive addition, that tells me that the larger number is going to be the positive. So 1 is going to be negative, 2 is going to be positive. And let's try this out. Negative 1 times 2 gets us negative 2. Negative 1 plus 2 gets us positive 1. So these are verified. They're good. So all I need to do now, what I need to do next, is set this up in our factored form. So remember, we use our variable, which is x. I subtract the 1 because it's negative, and then this is multiplied by x plus the 2 because it's positive, and we keep this equal to 0. Don't forget that part. We have to keep it equal to 0. Okay? So now, our new step, take each of these factors, x minus 1 and x plus 2, and we're going to set them equal to 0, right? And then just solve for x. So add 1 to both sides, x equals 1. Subtract 2 from both sides, and x equals negative 2. And these are both solutions, so what we're going to do is we're going to write them up as a set, kind of. This is going to be 1, comma, negative 2. That's our solution to number 3. Okay, so all we're really doing, we got to make sure that the equation is set equal to 0. We factor the trinomial, or we just factor. We set each factor equal to 0, and then we write them in our curvy braces. Okay, well, let's move to the back side, because most of the examples on the front page, as you can see, are going to pretty much be the same thing. So let's move on to the back. Okay, we're going to look at 3 in a row because these are some interesting examples. They're a little bit different than what we just saw on the front. So I want you to notice something about these examples here. Notice that they're not trinomials. They are actually binomials, which is interesting. It's new to us. Well, it's not new. It's not new, but factoring binomials is something we've done several times over. So these are quadratic binomials, and we know that because of the exponent. So in this case, I can't use the standard factoring as I just was. X Games is not going to help me here. So what I need to do, or there is a way that it could work, but what we can do, we're going to go ahead and do this. Notice that I can pull out a GCF. In a lot of these, I can pull out a GCF. In number 9, it just so happens that there is no numerical GCF. There's just x. And so if I factor out a GCF of x, let's see, x squared divided by x is x, and minus 8x divided by x leaves me 8 is equal to 0. That's how we factor with the GCF. Just pull the GCF out, and we go. So the interesting thing about this, we set each factor equal to 0, so that means x equals 0 is actually one of my solutions as well. We've also got x minus 8 equals 0. We're going to add 8 to both sides this time, and x is equal to positive 8 as well. So I actually have 0 for one of my solutions in this one, and then I have positive 8. If you're looking for some challenges, try number 10 out. Number 10 has a greatest common factor of 3x. We're also going to look at number 11. Number 11 is actually similar to number 10. So if you're looking to check your answer or check your work, it's going to follow similarly. Notice that notice that 6 goes into both 6 and 12. Both also have an x. So what I'm going to do here, I'm going to pull out the GCF, which is 6x. And that's going to leave me with an x minus 2, right? And we can check our work by distributing. So 6x times x, 6x squared, 6x times negative 2, negative 12x. Perfect. It works. So the new step today is that we need to set each factor, each thing, equal to 0. So now 6x equals 0, and x minus 2 is equal to 0. Well, the first one, you want to get x by itself. As trivial as this seems, you want to get x by itself. So we're going to divide both sides by 6 and find that x is equal to 0. So there's one solution. I'm going to circle this that way we don't forget it. The other solution is a simple one-step equation, just like we've seen so many times before. We're going to add 2 to both sides. All right, so x is also equal to 2 as well. Our curvy brackets are going to tell us that the solutions are 0 and 2. If you feel like trying 12 on, 12 is 8x squared minus 6x equals 0. find the GCF of that, factor, and then find your solution. We're actually going to move on to number 13. And number 13, I hope you noticed this, because this is another type of factoring that we've talked about before. This factoring is called difference of squares. Notice this. Notice that x squared is a perfect square. Square root of x squared is x. Also notice that 64 itself is a perfect square. If that's the case, the square root of 64, of course, is 8. Also notice that we've got minus. Because this is a minus and because these two are perfect squares, we can do difference of squares. So remember that the difference of squares is take the square root of the first one, which is x, add the square root of the second one, 8, and then do a second set of parentheses where we take the square root of the first one and subtract the square root of the second one. Right? Difference of squares. Now, we still have to keep this set equal to 0. And then what we're going to do is we're going to take each of these, so x plus 8 and x minus 8, and we're going to set these equal to 0 as well. Now, I know what you're thinking. If we look at this, you can already see that one x is going to be negative 8, and the other x is going to be equal to positive 8. These are our solutions, and it's easy to see because they're one-step equations. We're going to have to subtract 8 from this side, and then we're going to have to add 8 over here. So our solution, which we put in our curvy brackets, is negative 8, comma 8. I should say our solutions. It's not a solution, it's solutions. This is why it's different from system of equations. In systems of equations, recall, we had coordinate points. That was one solution. Now, these are not coordinate points because we have two solutions. Make sense? All right. So 15, 16, and 14, those are all difference of squares as well. Try those out if you're interested. We're really going to end on number 17, because there's a simple idea in this. Notice that each of these equations do not equal 0. In number 17, I have x squared plus 4x equals 21. In 18, I have x squared minus 45 equals 4x. None of these equations equal 0. And so notice what we have. These are equations not in standard form. Standard form, for anyone who's wondering, is usually when the equation equals 0. So basically, when we say not in standard form, we mean, let me put it this way, does not equal 0. All right? So the only thing that's really different about these is that we're going to have to move something to the other side, then factor, then solve. All right? Now, that sounds funky, but here's the basic idea. We want a trinomial or an equation to equal 0. So I'm looking at number 17, and I don't want x squared plus 4x equal 21. I want x squared plus 4x plus something else to equal 0. So what I want to do, I want to move this 21 to the other side, because when we do that, we're going to have 0. We're going to have nothing, right? We're going to have nothing on the right side, and 0 represents nothing. So to move 21 to the other side, do you remember how to do that? All I have to do is the opposite operation. So I am going to subtract 21 from both sides. Now, because it doesn't have a variable, it's not going to combine with the x squared or the 4x. So I'm actually going to have x squared plus 4x minus 21 equals 0. All right? Now, this is exactly what we want. This is a quadratic equation set equal to 0. It's in standard form. So now what we need to do is factor it according to the steps. So factoring it, I'm actually going to use the x games because this is a trinomial. This is not difference of squares, and there's no greatest common factor. So we're using x games. Remember that. No difference of squares, no greatest common factor, x games. All right, let's see. My c is negative 21. My b is 4. So we need to find factors of 21 that either have a sum of 4 or a difference of 4? And I already know 1 times 21. Okay, no. 3 times 7 will be the other one. Well, guess what? 7 and 3. How do I get a positive 4? 7 minus 3. And believe it or not, that works because 7 times negative 3 gets us the negative 21. So this is perfect. This is exactly what we wanted. So I'm going to write this in factored form. My variable is x. So x plus 7, because 7 is positive, times x minus 3 equals 0. Now that it's factored, we need to write each of our factors and set them equal to 0. So that way we can actually solve. So x plus 7 equals 0, and x minus 3 equals 0. Okay, subtract 7 from both sides. X equals negative 7 here. But also, come over to this one, add 3 to both sides. X also equals positive 3. Okay, so my solution, or I should say my solutions, are negative 7, comma, positive 3. That's fantastic. So if you're still not sure not quite sure what I did or why I did what I did, here's the rundown. In each of these problems, you want to get whatever's on the right side back over to the left. We're trying to get this thing equal to 0. So we're going to have to move each of these things over. That way our equation is set equal to 0. Okay? The opposite operations is how we accomplish that. So make sure that you're using opposite operations to add or subtract from both sides. All right? This should be enough to get you started. If you have any questions, hit me up. I'm here to help. Otherwise, until we see each other again, let me tell you this. Past, present, and future walk into a bar. It was tense. Thanks for watching, guys. I'll see you later.